Right, so we have this kind of scary integral here that is from an Imperial College engineering exam, which, by the way, kind of fucked me up back in the day. So I'm quickly going to go through how we're gonna solve. So if you remember that this, we can kind of see that this looks similar to something that we might know. So if we think about the d by dx of u over v, what does this equal? It's the quotient rule, so it would be v du minus u dv all over v squared. Now, what can we see? E to the sine 2x has to equal v squared on the bottom here by this rule, which it does in a way, because we can write that e to the sine 2x is equal to e to the sine x all squared, which is a power law, basically. So now we can say that v, pen works, equals e to the sine x. So that's one part done. So we can say that dv equals, how does your pen rub out? Okay, how do we do this? Well, the differential of e to the sine x is the differential of the power times by e to the power. So it'd be, what's the differential of sine x? Cos x times by e to the sine x, which we can see, we're kind of seeing, which is this part here, which is dv. So it's looking nice. So u, if we compare the two, compare dv to this, which we have, and u, we can say that u, I'm going to try another pen. Third one's the charm, kind of. So we're saying u equals x squared. Not really. So we have, if we find du equals 2x, and we put this together, on the top we have v du, so v du minus u dv all over v squared. So the integral of this, pi over 2 and 0, being the boundary conditions is just a question, is equal to, going back to here, so if we integral this, we'll get the differential this, get the integral. Just go in, they go in and out of each other. It equals u and v, which is fucking horrible. If you can see that, you probably can't. So this integrated, which is this integrated, equals this. So the answer of this is this of u, which is x squared, over v, which is e to the sine x. Between pi over 2 and 0. So we know that the 0 term here will just be 0, because 0 over anything is 0. So we just need to do the top pi squared one, which equals pi over 2 squared over e to the sine pi over 2 sine e. That is actually disgusting. Which equals pi squared over, it's like it only works in certain parts. Interesting. Pi squared over 4 over sine of pi over 2 is 1, which is e to the sine 1, sorry, e to the power of 1, which equals e. That's the power of 1. So we've got pi squared over 4 all over e. So if we write that here, pi squared over 4, might be easier to see that it's like divided here, divided by 4, no, divided by e, equals pi squared over 4 times 1 over e, which equals pi squared over 4e, which is the right question. I'm Louis, I'm an engineering student at uni, and this is the question from the Imperial College exam at Room of Life. So this is the correct answer. Thanks.